Today we're going to look at an introduction to topic 13. Topic 13 deals with operations and algebraic thinking. So it's about writing and interpreting numerical expressions and using parentheses, brackets, or braces in numerical expressions and evaluating with those symbols. So we're going to follow the order of operations. You have some exposure to this. We've done that this year. In IE, and we've had some bonus questions on test. And that means when you have an equation that has more than one operation, you need to do the steps in a certain order. The very first step you're going to do is anything that's in parentheses. If there's no parentheses, then you go to the second step and you would solve any exponents. Once those are solved, or if there were no exponents, you move on. This is the kicker here. This should be understood and interpreted as multiplication or division. Hi, Brandon. Multiplication or division, meaning that if division comes first, left to right, you would divide first. This step, they both are equally important. So it's a parenthesis step, it's an exponent step, and then it's multiplication or division as one step. And you work always from the left to the right in solving an equation. The same is true of addition or subtraction. Once you've gone through and done any parentheses, you've done exponents, you've multiplied and divided. Now you're left with an equation and you work left to right, adding or subtracting from left to right. Some people like to remember this as what we say PEMDAS, taking the first letter of each word, or please excuse my dear Aunt Sally. Those are good tools to remember. The only thing that I don't care for on those is that you need to understand these are not two separate steps. This is one step together, multiplying and dividing, and then adding and subtracting. So please excuse my dear Aunt Sally is a great way to remember it. But do not mistake it that you would always multiply before you divide. That only works going left to right. Okay, so let's try this one. In equation, I have multiple operations. A good strategy a lot of people use for this is PEMDAS along the side. So I'm just writing the first letter. We'll deal with some parentheses today. This particular equation does not have any, so check. There are no exponents. Check. Now it's a multiplication or division step, and this goes from left to right. So in this problem, you see I have division and multiplication here, but division's first. So the first way I solve this is 12 divided by 3. Well, that's 4. Then the equation reads like this. I do one operation per step. Your 6th grade teachers are going to want this pizza method written showing each step. That may seem silly to you now because you're figuring I could do this in my head and solve it. I know you can, but the problems aren't always going to be this easy. And if you don't have this practice of writing each step, you're going to have to relearn that when the math becomes more difficult. So now I've done divided, I still need to multiply. This becomes 4 plus, now I multiplied that there, 20. Okay, 4 plus 20, there's only one operation left, it's addition, and then I solve it. The whole problem equals 24, and that's why I call it pizza, because it looks like it could be a piece of pizza. Once again, food and math. Okay, so you try this one. Please remember PEMDAS. Well, how did you do? Did you say that the answer to this problem was 34? Did anyone say 54? Right, you have to do 5 times 6 first. You don't want to, you'd multiply here before you add. So multiplication comes before adding. We haven't done a whole lot of exponents in 5th grade, nor is it required that we do. But think about this problem. This, you solve parentheses first. Well, what's the solution of the parentheses? and then use to the second power. Whoops, they both went away, 100. And then my last one, I tapped it twice. So let's see how we get 96 for this last one. First thing I do is parentheses, so this is 10 to the second power plus 24 minus 14 times 2. Well, parentheses done, exponents. 10 to the second power, we just solved that above, was 100. And plus 24 minus 14 times 2. All right, now I go through and starting left to right, I look to multiply or divide. 10 plus 24. Nope. 24 minus 14. Still subtraction. I'm not there yet. Ooh, 14. I have multiplication here. So it's 10 plus 24 minus 28. And now I get to adding and subtracting. 10 plus 24 minus 28. 100 plus 24. I'm sorry. So 100 plus 24 is 124 minus 28. And then that's where you get that answer. 124 minus 28 is 96. 2 students evaluated this expression and got 2 different answers. Neither student made a mistake in the calculation, so how did they get different results? Right, they didn't solve using the correct order of operation. What is the correct result to this problem? Order of operations tells me I would divide first, so it's 15 plus 4 plus 5. Then it'd be 15 plus 4 plus 5. And then it would be 19 plus 5, and that's where I get 24. Let's see what the 2 students did. Well, Charlie did it very similar to how we solved it. And he did the steps singularly, like your 6th grade teachers are going to want you to do, and he got the same answer. What did Cameron do? Right, she didn't follow the order of operations. She just went left to right. So she did 15 plus 12, got 27, and then divided it by 8. So Cameron needs to follow the order of operations. So the big essential question to this is, how do you evaluate, which is a fancy word for solve, a numerical expression with more than one operation? So if 2 students evaluate the same numerical expression but got different answers, to avoid getting more than one answer, use the order of operations, which of course you know is parentheses, exponents, multiplying and dividing, adding and subtracting. Okay, Rebecca's way, Juan's way. Well, Juan's way and Rebecca's way get 2 different solutions because one followed the order of operations and one did not. So 36 plus 9 divided by 3 times 5. So Rebecca says, well, this is 36 plus 3. 9 divided by 3 is what she solved, times 5. Then she did the multiplication and got 15. 36 plus 15, and she got a solution to a 51. Juan's way is one way to do it, but it is wrong. Get it? Juan's way, sorry. All right, so 36 plus 9 divided by 3 times 5. So he adds 36 plus 9, gets 45 right off the bat. Divides by 3, gets 15, and then multiplies by 5. No one should do it that way. Get it? Okay. So use the order of operations to solve it. Multiply and divide in order from left to right. And then finally subtract and get your final answer. Insert parentheses to make this statement true. So if I have 3 plus 5 times 2 minus 10, I want it to equal 6. Well, play around with it. If I insert parentheses, it means I do it first. Well, I'm probably not going to insert parentheses around 2 minus 10 because that's going to give me negative. What if I did parentheses here and I said, 5 times 2? Well, 3 plus 5 times 2 becomes 3 plus 10 minus 10 equals 6. No, that's not true, is it? We don't want to do it that way. So let's think of another way. Oops, sorry, I erased my 2. Okay, so this is 5 times 2. So what if I put my parentheses here? In 3 plus 5, I get 8 times 2 minus 10. 8 times 2 is 16, minus 10 is 6. That's where I want my parentheses. Well, if I have another problem here, I want to work left to right, following my order of operations. Following PEMDAS, what answer do you get? Parentheses first. 3 divided by 3 plus 4 times 2. Now I multiply or divide, but I start left to right. So I have division first. 3 divided by 3 is 1 plus 4 times 2. And then I need to multiply here. 1 plus 8. My answer is 9. Do one more for us here. Okay. 64 divided by 8 times 1/2. Order of operations. I need to divide first. Right. 64 divided by 8 is 8. 8 times 1/2 is 4. And that is the same as 8 divided by 2. Remember, I could flip it and take the reciprocal. Okay, so 8 times 1/2 is 4. There you go. I think you're ready for some practice. Today's practice is on something called Go Formative. And it's just a neat way. It'll grade it for you and send me the results. You don't need to submit anything. Just a new way to practice. All right, kiddos, I'm proud of you. You are amazing. You've got this. We'll see you. I say see you soon. I still wish I was, but I do have a Zoom meeting that you can attend.